In this video, I am going to tell something about force and laws of motion. Force and laws of motion. So, according to Newton's third law of motion, to every action there is equal and opposite reaction. Third law of motion, it states that to every action there is equal and opposite reaction. Every action has equal and opposite reaction. Now, but they work on two different bodies. Okay. The force of action and reaction are always equal and opposite. Is that always equal and opposite? So this act on two different objects and never cancel each other. Yes, they never cancel each other. Each force produces its own effect. Yes, each force produces its own effect. Each force has its own effect. Now, though action and reaction forces are always equal in magnitude, yet these forces may not produce acceleration of equal magnitude. The acceleration produced by action and reaction may not be equal in magnitude. Okay, this is because each force acts on different object which may have different masses. Yes, the acceleration produced by a body is directly proportional to the mass. If mass is more, then the acceleration produced will be more. For example, suppose if I throw a ball on the wall, the ball bounces. Okay, the wall makes the ball move in the opposite direction, but the ball does not move the wall. In the direction of the force. This is because the mass of the wall is very much as compared to the mass of the ball. So acceleration produced on two different bodies by the action and reaction is not the same. It is here because their masses are not same. Now, some examples of Newton's third law of motion are walking, walking, swimming, recoiling of gun, man and boat, flying of rockets and jet planes, in case of hose pipe, that is used to extinguish fire. Hose pipe, that also works on the third law of Newton. According to the law of conservation of linear momentum, when two or more bodies interact with each other, the vector sum of their linear momentum remains the constant. The vector sum, vector is a quantity which has both magnitude and direction. So the vector, sum of their linear momentum remains the constant it is. So once again I am repeating, according to the law of conservation of linear momentum, suppose a ball A is striking with ball B in a straight line. That is a linear momentum. When two or more bodies interact with each other, the vector sum of their linear momentum remains the constant it is here. Yes. So the linear momentum means momentum in the beginning before the ball strikes, and the momentum after the ball has struck. so they are equalities. ओके, यानी बॉल के स्ट्राइक होने के पहले और बॉल के स्ट्राइक होने के बाद का जो मोमेंटम है वो इक्वल होता है. यस, नाउ all okay applications, examples of Newton's third law of motion can be explained in terms of the law of conservation of linear momentum. Yes, this is important one. All applications or examples of third law of motion can be explained in terms of the law of conservation of momentum. So when a bullet is fired from a gun, bullet is fired from a gun, the gun recoils. Recoils means the gun moves back. The gun moves backward. So the recoiling velocity of the gun, v2, recoiling velocity. How do we find the recoiling velocity? So that is equal to m1 into v1 divided by m2. Yes, what are m1, m2, v2? Okay, listen. Where v1 is velocity of the bullet. v1 is the velocity of the bullet of mass m1. m1 is the mass of the bullet, v1 is the velocity of the bullet, and m2 is the mass of the gun. m2 is the mass of the gun. So the simple formula for recoiling of gun is m1 v1 divided by m2. m1 v1 divided by m2. m1 and v1 are the mass and the velocity of the bullet, and m2 is the mass of the gun. It is clear. So that is the recoiling velocity. Recoiling velocity it is. Now in this okay, you can use to find the velocity of recoiling velocity of a gun. Let me explain how walking is an example of third law of motion. How walking is example of third law of motion. To walk on the ground, we push the ground backward. Yes, with our feet, we push the ground backward with our foot alone. Okay, as a reaction, the ground pushes our foot forward with the same force, because the action is by the foot on the ground, and the reaction is by the ground on the foot. Okay, so in this way, forward reaction force of the ground that enables us to walk. Okay, forward it is now. So since the ground pushes us in the opposite direction, we push the ground, and the ground pushes us in the opposite direction, and that makes us walk smoothly on the ground. Okay, so walking becomes difficult when the ground is slippery. Yes, when the ground is slippery, it becomes very difficult. Or if it is covered with snow or sand, then also it is difficult. It's okay. This is because we can exert much small force on the form of backward reaction on the ground. Because we can exert much smaller force in the form of backward action on the ground. Okay, the forward reaction of the ground will reduce accordingly. Yes, because we cannot push the ground with great force because the floor is slippery or it is covered with snow or sand. Okay, in the same way, as a reaction, the ground will not make your foot move forward. Okay, and that is why it is difficult to move on slippery or snowy or sandy ground. It's okay. Okay, thank you.